Well, this is set up as a substitution problem. We're told that x is equal to this whole thing. So let's take that whole thing and put it in place of x there. Okay, I've got a 4 times 2y minus 3. Take a moment there and look. I'm defining x by this equation, and then I'm using x in the next equation. So if I know that x can be represented by 2y minus 3, then instead of 4x, I'm putting 4 times 2y minus 3. I still have the minus 5y, and I still have it equal to negative 3. This equation is that equation, but instead of x, I've put what x is told to be representing. So then it's just to distribute the 4 and combine your like terms type of a situation. So that's an 8y minus 12 minus 5y equals negative 3. So here we don't have any x's. That's the point of the substitution now. 8y minus 5y is a 3y. If I add 12 to both sides, I end up with a 9. 3y equals 9. Divide both sides by 3, I get y equals 3. Now, what do I do with that? Well, the answer is going to be a point, an x and a y, and my y value is 3. Usually in a substitution problem like this, the thing that you solve for is something you can plug into your original equation that will give you your other value. So x is equal to 2 times something minus 3. If that something is a 3, then that means I'm taking 2 times 3 minus 3. Well, that's 6 minus 3. 6 minus 3 is in fact 3. So my x value is also equal to 3. So 3 is the solution. You can kind of do the same thing here. Take this, plug it in there. And for this one here, since we're just kind of right here, this is called the linear combination or the elimination approach. Okay, we want to eliminate, let's say, the x's here. And to do that, I would need to multiply this equation by a negative 2. So if I do that, I multiply by negative 2, I get a negative 10x, I get a plus 6y, and I have it equal to positive 4. Okay, now if I try and add these together, that and that go away. I have a 0. That and that also go away, so everything on this side is equal to 0, but a 4 and a 4, some of you are going to say, oh, everything cancels. But no, it doesn't, because that's a positive 4, and that's a positive 4, and that's 8. And by the way, 8 is not equal to 0. So in that case there, your solution, well, your answer would be no solution, because 0 doesn't equal 8. We have evidence. All of our variables went away, and we had a statement that was not true. So that the response then would be no solution. Now, if this was a negative 4 and a positive 4, and it was a 0 equals 0, well, that would be true all the time. So if the variables go away and the statement is true, instead of no solution, we would say many solutions, or an infinite many solutions, or all the real numbers. There's various ways of saying that. Just make sure you see the difference. Something like this would be no solution. If it was 0 equals 0, we would have many solutions.